Hi, my name is David Spaeth. I'm part of the North America SWAT team for Information Server. And today I'd like to talk a little bit about the DataStage capability to load directly into Salesforce, specifically the bulk load capability. I'd like to start off first, though, spending just a couple minutes talking about the Salesforce API itself. This will help enable the DataStage developer to have some understanding of the characteristics of the API and how the connector can be leveraged, as well as some of the limitations that are imposed by the API itself. First, let's talk about the architecture from the Salesforce perspective. I'd like to discern the difference between what we call a DataStage job and what Salesforce refers to as a load job. A DataStage job represents a mapping flow. Salesforce, a job is representative a set of data files, batch files, that are all associated to a given job. A job has an identifier that is handed back to DataStage when we initiate a Salesforce job, and it also produces, Salesforce will produce a unique name for each batch file, i.e. a batch ID. Let's start on the left-hand side first. Using the REST API, DataStage, in this particular case, looks like the client. We initiate a connection to Salesforce, which represents that middle box initially, and we create a load. That will return back from Salesforce a job identifier. Again, that's a Salesforce job, not a DataStage job. DataStage will then produce some number of batch files that is dictated by the parameter batch size within the Salesforce connector on DataStage. In doing so, what it'll do is create a number of records within a temporary directory on the DataStage server. It will compress those via zip or gzip and push those individually up to Salesforce. It can process those in parallel based upon a configuration parameter set within the DataStage job at runtime. So I can choose to run a DataStage job that will load Salesforce serially, or some number of parallel threads loading concurrently into Salesforce. Once the data has been pushed up to Salesforce, it will automatically be queued within the Salesforce process servers. There is no way to determine the sequence that a given batch file will be loaded within Salesforce. It just grabs them randomly, and that's determined based upon the load upon the Salesforce server itself. Once a given batch file has been loaded and it's inserted or updated those records into the target, there's a result file that represents each record that was inserted or not within that batch file. Those go back to representing the job group, if you will. And within DataStage, there is a capability within the connector to check the status of each of those batch records. What you'll get if you have a DataStage job using a reject link on the Salesforce connector, it will return back to you the error produced by Salesforce, as well as the data record, if you choose, that was being loaded. So you can see the actual record, the data that was being loaded, and the failure and why it failed. When we look at DataStage in a few minutes, you'll see how we're able to manage that. Let's take just a couple minutes to look at some of the limitations that the API itself has. There are some usage limitations associated with not only your license with Salesforce, but also the maximum number of batches that can be submitted within a 24-hour period. A couple things to note. The content or payload that's pushed up to Salesforce with the API can either be in CSV format or XML. We use CSV and we compress the data to maximize the bandwidth of the network. Some other aspects. The maximum number of records within a specific batch file is 10,000. If we take a look at the number of batch limits, which is 5,000, and the maximum number of records within a batch itself, you can load a maximum of 50 million records in any 24-hour period. One other note here is that the DataStage Salesforce connector also supports the ability to load binary data. Let's take a little bit closer look at the batch results that you get back from Salesforce when you load data. It's critical to understand what it's doing so that based upon your load technique, how would you choose to reconcile specific record failures? So if a given batch file loaded into Salesforce has 5 records and one of them fails, the batch itself can be declared success, but the record within the batch that failed will not have been loaded. However, all of the other records that were successful will not be rolled back. They are committed. In this example where we're looking at CSV batch results, there are 4 fields that are returned back to the status requester. The ID, which represents the Salesforce unique identifier that was generated at the time of create, a success flag, a created flag, and an error attribute. So what we have on the 3rd row of this result status is it's showing us that there was no ID generated for the 3rd record. It was not successfully loaded, nor was it created. There is a return error status, which gives us a clear understanding of what failed within the record. In this particular case, it's the last name field, which the object within Salesforce has been flagged as a required field. In a database perspective, you might see that as a non-nullable field. How do we handle those rejected records? If Salesforce only returns back a subset of what their status is, but not the entire data record, how do we understand, as a developer or an exception handler, how would we translate the errors coming back from Salesforce to the data that was actually loaded? Recognize that batches, if we have 20 batches within a job load, there is no correlation between the sequence that those batches are loaded and what you have sent up. However, there is a correlation between the records within a given batch and the result set returned from Salesforce. So each batch that's pushed up to Salesforce has a corresponding result file coming back that represents the batch and the record position, if you will, of the failed records. So just keep a note of this. Effectively, what we would need to do is identify the position within this result file from Salesforce and translate that to the same record position, row number, within the batch file that we pushed up. Now that we've taken a look at how the documentation for the API is from Salesforce, let's take a look now at DataStage and how we manage the loading and potential exception handling. Here I've created a simple job using a capability within DataStage that will generate sample data for me. Let's view this real quickly so that we can see the type of data that it's going to generate. Remember, this is random data. It does it based upon the data type and the definition that you have on the attribute or column name. What I'd like you to notice is that this object that I'm loading has 3 fields: an external ID, first name, last name. In the row generator that I have here, I've flagged that the external ID can be nullable. So it will randomly generate a null value for that particular column. The values you see under first name and last name are just random data that it generates based upon the data type. The reason I'm showing you this is when we start to look at the batch data, it'll give you some understanding that DataStage is generating this data. This DataStage job will generate 100 records, and of those it'll generate 32 rejected records based upon the setting for generating null values in the external ID. The connector itself, using REST API for Salesforce, will under the covers generate a batch file based upon the number of records in the batch properties. I'll show you that in a moment. It will compress each one of those batch files and upload those to Salesforce. If I have multiple parallel definitions, I'll be loading and creating parallel batch sets and moving them up in parallel to Salesforce. I can set that to 1 or some large number like 20 or 30, which is something that you would want to tune based upon your environment and the throughput that you're looking to achieve. The item that I have pointed to here, the Salesforce bulk load temp directory, is used to determine where the temporary files, these batch files, are stored on the DataStage server. We're taking advantage of that functionality so that we can later process the data records and translate them to the rejects that were produced from Salesforce. The properties within the connector itself are standard connection information that you would expect. The username of Salesforce, the password, the URL, which includes the API. You can choose to have a proxy server if you want or required, and the write operation that you're looking to do. In this particular case, we're doing an upsert. I'm choosing to do a bulk load versus real-time. Real-time will use the SOAP API instead of the REST API. We also are preserving the job ID that's created within Salesforce in a file directory. We're defining that we are loading this in parallel versus serial. And again, I'm saving the temporary batch files in their directory so that I can refer back to them later. Notice that I have the batch size set to 5. By setting the batch size to 5, each batch file that's pushed up will have 5 rows in it. That means that I'll have 20 batch files for the load run. Once I've loaded these records, I can then go back and look at Salesforce to see what Salesforce says about the load itself. So let's take a quick look here. I've logged into Salesforce and I've got into the area where I can monitor the bulk loads themselves. In this particular example, I'm looking at a batch that is currently loading. Now in actuality this is already loaded, but I saved it off so you could see that I can monitor in progress the job that's being loaded. And now let's take a look at the detailed representation. So the job in this particular case has now completed. What I want to do is I want to go look at the details of this job. Now that I've selected to drill into the detail of the job load itself, I can see the job ID, and we'll translate that later in a few minutes. I can see what the object was within Salesforce that I was loading. If there was an external ID, what the name of that column is, that I was loading via CSV versus XML, that I was loading it in parallel. Again, those are all references from within DataStage. The API in this case I was using 27. I was using upsert. There were 20 batches that were completed. Total number of records sent up were 100, and 32 of them failed. If I move down just a little bit further, what you'll see is references to the batches within that job run. Ultimately, there are 20 of them, and I can see at this level, the high level view, of the number of records processed and the rejects. In this particular case that I'm looking at, have highlighted, is I have 2 rejects. So if I take a look now at what DataStage has done, I come back to my DataStage server, and we have flagged to save or preserve those temporary files, which again represents the data files. So I have 20 files in here. The naming convention is the object that's being loaded, the job ID, and the unique batch ID within the job. And if I drill into the data, this is the data that DataStage created for this particular batch file, and you'll see that it looks just like what I showed in the view data for the row generator. You can see that the external ID on rows 3 and 4 are empty. To look at what the result of the batch status is, we can look and see now what was returned looks very similar to the documentation provided by Salesforce. Again, we have an ID field, a success, a created, and error field. The ID here represents what was produced or generated by Salesforce, and in this particular case, these 2 records were loaded and there was no error. The next 2 records, we can see that the external ID was not present, and therefore it was rejected. If we look now, we need to translate row number 3 and 4 to what was produced within the data set. So row 3 and 4 here are the rows that represent the data that was rejected. So now what we need to do is translate those or correlate those together. So how might we do that? Let's take a look at another DataStage job that is designed to run post-run, meaning after this is loaded, and derive the specific errors that are within the data itself. So this particular job takes advantage of a couple advanced features. In this particular case, we're going to set a environment variable which says that we're using a pattern file set. A pattern file set enables the sequential stage to include a new column that's generated. That column will have the file name that's being processed. So let's think about that 1 second. I go back to where my DataStage temporary files are at. I have a wide variety of names that represent the data itself. What I'm going to need to do, since the actual rows or the detail data does not have the batch ID and the job ID, I'm going to need to translate those or resolve those through the file name. Going back to the job itself, I'm going to read in the entire record, the data value, as a column. So the entire row of that file, that batch file, is going to come in as a column within this job. And the file name will represent the actual file name. So let's take a quick look at what that might look like. This is going out now and resolving the actual files that we're processing, and you'll see that the row data column has the entire record in it, and then on the right hand side we have the full path and the file name. What we're going to want to do in order to translate and correlate the status coming back from Salesforce is we're going to want to add a batch and row number and job ID to the data coming through. So what you'll see here is I'm parsing off that file name field to get and resolve the job ID and batch ID, as well as generate a row number within the batch itself. So once I have that, I'll be able to use that to look up within Salesforce or the result of the bulk status and join those to get the actual data that I'm looking for. This transformer, after we read the bulk status for each record, is doing something very similar. I'm breaking apart, getting the status, and then I'm going to return the status for the same job ID, and batch row number. That's using a lookup. We're also filtering out within the transformer coming back from Salesforce to only return those records that failed. There's no sense in looking up all the data or storing all that data for lookup when we only need a subset. In our particular case, there's only 32. I'm then writing those out to a data set for further processing or analysis. If I take a look at the rejected data, we should see the reject reason and the record that caused the failure in the first place. So now what we see is we have the job identifier, the batch ID, the batch row number respectively, and the reason that it was rejected, and lastly the row data record itself. Now if we chose, we could then further parse that record that's returning back to be the discrete values or not. We have the data, we can choose to do what we want with it within DataStage. Alright, now that we can see how that process works, you can see that I went through several steps to look at this and look at that and bring it back together. Well, what if there was an easier way to do that? Well, there is. I can simply do the exact same thing by simply putting a reject link off the bulk loader. So if I go into the bulk loader stage now, what you'll see is that I have now an output tab because I've included a reject link out of the stage. Within the properties of the output, I can select to determine whether I want to write the rejected errors out, which I do, and then what do I want to include? I want to include the error text in my case. I could also choose to force an abort of the job after some number of records have been rejected or a % of the records have been rejected. The actual columns that are on the output include the input data that was being loaded. So what might that look like? What we'll see here is exactly what we saw on the other side. except the columns have been parsed out for us. So the DataStage Salesforce connector will manage behind the scenes exactly what I showed you within a single job using the reject link. Now, why would I want to use one over the other? Well, sometimes you may be loading data and the time that it takes to load the data in the background for Salesforce may time out the job. You do have some controls over the timeout and retry settings, but at some point in time, it may time out, or the job may fail, or who knows, something else. In this particular example, you can choose to do this first if you want, and then have a separate job that does the recovery as I showed in the first step. So what I've shown you is I've shown you the specific API references from Salesforce. I've shown you how, using their documentation, how to reconcile errors and do error handling manually by taking advantage of DataStage and its ability to associate data from multiple sources. I've also shown you the capability within DataStage to very easily capture and handle the rejects coming back from Salesforce. I hope that you found the content that's been covered here to be useful in your usage of DataStage's Salesforce.com connector. Thank you and have a great day.